Now let's install Red Hat Enterprise Linux on another Dell system. This box will allow us to boot from the CD-ROM and connect to the network and install across the wire. The default is to install or upgrade the system. This system currently has a different operating system on it, so we'll override it. But we like to pass in options as we've done already, including the location of a repository, in this case Red Hat Enterprise Linux 6, located on our Debian Apache server, as well as restrictions on resolution to 800 by 600 so that it fits within our display, and optionally IP addresses and related information such as netmask gateway, DNS, etc. Now we'll select the basic video driver option because otherwise the default for this system is to propel into 1280 by 1024 resolution, which is a bit large for our intents and purposes. So let's go ahead and tab to modify the basic video driver. This will use the VESA driver, which is an option that you can pass into the kernel to restrict the resolution. So we'll tack on our options, which include location of the repository on the Apache server at 101 in the Linux CBT subdirectory, EL6, miscellaneous, rel6. This is the directory that we recently set up as the installation source tree. Let's set the resolution to 800 by 600. This will work for this system as opposed to the other system where the memory limitation prevented the graphical installation from proceeding. This system has 2 gigs of memory, 4 times the memory, and as a consequence the graphical installer will work. So let's go ahead and set the IP address equal to 1 up from the server to 21. The same netmask, 24 bits. And the gateway is also the same, .1. And the DNS will also be the Debian box, 168.75.101. So these are the directives that we'll move forward with. We may optionally specify VNC here, which will start the listener as we've recently explored. But since we're going through a normal graphical installer, which is being performed locally, presuming you have access to the console of the system to perform this type of installation. So the presumption here is you're at the console, you have physical access, and you're passing in a few parameters controlling the repository as well as the resolution with which the installation is to be performed and the IP address, and to do it with the basic VESA driver. So let's move forward. This flips the resolution. And this initial section is always in text, which allows us to determine whether or not we'd like to check the media. So let's skip it. And the Ethernet interface has been configured. And whenever you see retrieving install.image in the case of a network-based installation, you know that your client has access to the installation source tree on the server. So with that said, let's proceed with the installation as usual. This is graphical install mode. Select the desired language and keyboard. As mentioned, there are various storage options. We can use specialized storage, such as FCO, for example, which is fiber channel over Ethernet, or otherwise. But we're using local storage, so we'll stick to the local hard drive as a reference. If you're using iSCSI or FCO or otherwise, that may be an option for you. Let's label this host Linux CBT serve2.linuxcbt.internal as its second and top level domains. The offset's correct, and the system clock does use UTC, although we did not spend time looking at the BIOS. Let's indicate the password. And if you're using LDAP, you can configure connectivity once the system is up and running. However, even when using LDAP, there's always a locally defined root user. So the options here include whether or not to replace the existing system, or to use all of the space, or replace the existing Linux system, that is, or use all space, shrink the current system for resizing, use free space, create a custom layout. Because the system has greater than 50 gigabytes, the proposal that Anaconda automatically configures will be the default. So let's go ahead and use all space. We can also encrypt the file system. And here's an option to review and modify the partition proposal. That will be presented momentarily. Let's move forward. So here's the proposal. So it seems as if the proposal is to create a volume group named VG_hostname, short hostname, which is the template that's used for generating the name of the volume group. Again, it's a VG_ prefix followed by the short hostname. In addition, there are volumes for root, home, and swap. As we've mentioned, that's a default behavior. Also, there's a proposal to place outside of the logical volume management scope a boot partition that's 500 megabytes, which facilitates ample upgradability. And then we see a physical volume defined on SDA2, which is lumped into the overall logical volume management. So if we look at the full storage, it seems as if logical volume management uses of the 80 gig hard drive SDA, and we can see the full size of the drive, and we see it uses about 75 gigs. We look at the layout, we see that the bulk of it is for volume group LV_root. The remaining space, or the bulk of the remaining space, is for the home partition, and the remaining space is for the boot partition, as well as for swap. So swap's lumped into the volume group as well. VG_Linux CBT serve 2. So looking at it from a hard drive perspective, SDA is the lone drive on the system, and this version of Red Hat Enterprise Linux no longer references drives, in particular TAPI drives, using H prefixes, but rather simply S prefixes, so SDA, SDB, SDC. And more specifically, there is a trend towards referencing the location on the PCI bus for further accuracy in the event that the simple labels SDA, SDB, SDC, and HDA, HDB, HDC, which have been deprecated, become rearranged during startup, because the assignment of those simple names take place during startup depending upon how the kernel detects the hardware connected to the bus at that particular time. So there is room for confusion, whereas the actual physical location on the bus will not be confused, unless, of course, you plug physically the device into a different port, switching it, let's say, from PCI port 0 to PCI port 1, or vice versa. So, with that said, this is the proposal of how to cut up dev SDA, to use the bulk of it as a volume group and a small piece of it as the boot partition outside of the logical volume management scope. So the swap partition is within the logical volume management scope. Also note that the swap partition here is considerably larger than the swap partition on the server, Linux CBT Serve 1, which contains 512 megs of memory. In this case, because this system contains 2 gigs of memory, the swap partition is double it, or 4 gigs of memory. So note that depending on the number of gigabytes or megabytes available for memory, you will determine how much bigger the swap space that's allocated, but usually the rule is double. So this is the layout. You can make changes or accept the proposal. Now, the disk is going to be encrypted, which means the contents cannot be read without the encryption password. This is a password that you do not want to lose, otherwise you will be unable to recover data from your drive. But of course, the purpose of encrypting it is simply that, or exactly that. So the partitioning options you've selected will now be written. This is a stage where changes are actually committed to the disk. As we've mentioned, data aren't always or usually lost as a consequence of formatting or partitioning. Data may be recovered using the appropriate tools, providing you have not overwritten the data with new data. So all is not lost immediately, but eventually older files will be replaced by newer files. So let's write the changes to the disk. This will set up the new proposal. Again, the tendency or trend is towards using logical volume management for laying out disks within the Red Hat Enterprise environment, as well as other distros as well, because LVM allows us much more flexibility with respect to how we allocate storage. So the logical volumes are being created, and they're all located, by the way, beneath the dev mapper directory, and they're prefixed with the volume group name, which takes on VG underscore short host name dash the logical volume name. We'll be looking at logical volume management later on, discussing the hierarchy and how to comprise them, the components that are part of them, and how they work, which will further explain what happens during installation. So we need a bootloader. The default is grub, and the default is to place it on the root partition. So, or to load the root partition, that is, but to place it on the boot partition to load the root partition. So the bootloader will load this instance of Red Hat Enterprise Linux from the root partition, but it'll be located in /boot, which is a lone partition of 500 megabytes outside of the scope of logical volume management. In order to make changes to the bootloader, we can secure it or require that the user, authorized or unauthorized, supply a password. Let's click OK, and that adds another layer of security to the system. All these options, by the way, can be scripted using Kickstart. So let's click on Next. We could add another entry in the event that there's, let's say, another distro or another instance of Red Hat Enterprise Linux that needs to be loaded by this bootloader. So supposing we used FreeSpace, we could add, let's say, an older version, V5, or another version of 6 to boot the independent version. Sometimes it's a good idea to maintain a backup version of the OS on the same hard drive to help you recover in the event of catastrophic failure booting, but the rescue option on the boot CD provides us with enough of an environment with the appropriate drivers to be able to recover in the event of turmoil. So here are the categories that are available: basic, database, web server, virtual hosts, and so on, desktop, etc. So we can take any of these, doesn't matter. Let's go ahead and make it a web server for now. We can always alter it at some point. And if you'd like a desktop, you can. Now, the last time we didn't make changes during installation. Let's go ahead and click on Customize Now. And this is where we see the groups of packages that are available to us. So the base system includes these packages: base, basic installation, the shell, key services, etc. Console internet, debugging tools, directory client for talking to LDAP, for example, dial-up networking, no longer is important, fiber channel over Ethernet, not used in our case, various monitoring tools, InfiniBand in the case of clustering, and a number of other key items that are excluded by default but available in the event that we need them. Perl support is always important. If you use smart cards, then that's an option. And if you have an iSCSI SAN, then install the iSCSI storage client to be able to connect to it. And the servers category, your Red Hat Enterprise Linux box can perform as a wide variety of servers, including a Samba server sharing out its file system, a backup server, so you can back up other systems and this system, an LDAP server, email. The current SMTP choice is postfix as opposed to sendmail or exim, and that is what you'll be tasked with managing in the event that you turn your Red Hat Enterprise Linux box into an email server. In the older days, both sendmail and postfix were provided with a switch utility, but now the folks at Red Hat are defaulting to postfix for obvious reasons, including but not limited to ease of configuration, FTP, NFS, NIS, and other items. So these are categories of servers that may be installed at any time. sysadmin tools, etc., web services. We've elected to install this server as a web server, which is why the items are checked. And if you install databases, MySQL and Postgres are the ones that are available. The clients are auto-installed because other tools rely upon their presence, their library presence. However, depending on your needs, you may need to install one of the database servers or both of the database servers. Since they operate on different TCP ports, it's quite feasible for you to run them in concert. System management, these are protocols that are used to manage a system, including the ubiquitous SNMP. Virtualization, KVM is provided, as well as Zen, to help you virtualize other operating systems on your system in the event that you have enough resources and you'd like to share those resources. Desktop environment, if you'd like to have, for example, a minimal desktop that can also be used as a thin client, then you can pick the desktop. If you want a general purpose desktop, then this is an option as well, which gives you additional applications, which we'll see as they come up. And there are packages that are tied to each of these items. Graphical administration tools, these are tools that help you to administer your system. And if you go to optional packages, you'll see those items that are not selected as well as those that are selected. The important ones are installed. For example, notice that system config kickstart is not installed. This tells us that by default it won't be available, and if you go looking for it to help set up kickstart, as we will be doing, then you'll have to install it at that point. We could save ourselves the hassle by installing it now. There's a GUI tool for LVM, but Red Hat's moving away from their GUI tools for the management of some of these services. So it's best if you know how to administer them from the shell using the appropriate commands. Like, for example, in the case of LVM, the PV, LV, and VG command sets for creating the 3 tiers of LVM storage types. So these are the GUI tools that are available. General purpose desktop, if we go to optional packages, we see that the bulk of the packages are installed. Sans 3 packages, DV grab, for example. If you're capturing from a DV device, like a camcorder, then that may be something that's of interest to you. It's actually 37 of 49, so 12 are missing. And a number of other items. There are fonts you can turn on, and this is for rendering in a variety of languages, etc. So depending on the content you come across on the net will determine whether or not you need certain fonts. And again, the desktop related packages are ideal in the event that you plan to use your Red Hat Enterprise box as a desktop. In some cases that is ideal, for example for scientific workstations or engineering workstations. Then perhaps you should install all of the desktop items or install the desktop, the client version of Red Hat Enterprise Linux, which will by default include the desktop environment. Let's also turn on X Windows support. This will ensure that we have a GUI. Remote desktop client allows us to connect outbound to Windows systems and VNC systems using RDP and VNC respectively. And there's also the option to configure KDE for those of you who like the KDE desktop environment. Support for the input of international text, so characters not used by your default character set. This will give you that flexibility in the event that you're using a system to communicate with others in other languages. And a number of applications, internet browser for example. Now the whole desktop category takes care of all of these GUI tools, installing them for us. Development items and various languages support. Install of course the languages that are important to you. So let's click on next and move forward. You get the sense that this section allows you to select from the main categories: base system, servers, web services, through languages. These categories can be manipulated once the server is up and running, non-issue. And typically that is probably the more ideal time to make those changes to your system. It's a good policy to install less initially and compound as necessary. Notice that the build this time will require just under 1150 packages, double our last effort. So we went from 219 to 500 and something to now just under 1150 packages. The more you install, the more packages are required. As we've mentioned, Red Hat Enterprise Linux varies in storage requirements from 3 gigabytes to 5 gigabytes for minimal to full installations, which by today's standards is a minuscule amount of storage. So on any system you intend to put EL6, you should have at least that much storage available. Ideally, you should also consider separating your installation from where you'll place your key files like the home directory or the var directory for the storage of databases or for the storage of users' home items. So for example, if you intend to use your server as an Apache and perhaps FTP server, then chances are you'll make heavy usage of the /home mount point, in which case you would want to consider placing the contents of home on a separate physical storage device to separate the I/O and to improve the I/O, keeping it independent from the operating system and thus improving throughput. So wherever possible, separate your I/O streams to different physical media to realize improved throughput. So this is moving forward. We're just beyond roughly 10%, and we should be done with this installation momentarily. The additional consoles are always available so you can see what's happening on the other screens. Just take a look using Control-Alt F1 through F5. 6 and 7 are there, but with no data. And as mentioned, there are a number of things that have changed with this release of Red Hat Enterprise Linux, including the location of the GUI when the system boots on Control-Alt F1, the change or switch from sysv init to upstart, although upstart behaves similarly, booting the processes in specific run levels and controlling them, starting them and ending them as appropriate. But nonetheless, it is a shift away from traditional sysv init to a new environment, as well as a number of other changes, including the move away from general names such as dev-sda to more specific names such as the location in the dev tree of the object on the bus, somewhere on the PCI bus. So this is moving forward nicely. Let's time-elapse it so that we can pick it up at a later point. So our installation has been time-elapsed and it is almost completed, at which point we'll reboot and the system will come up for the first time after having clobbered the Windows OS that was on it. And just like with prior versions of Red Hat Enterprise Linux, this version will store a copy of the Kickstart config file in /root. That's the Anaconda KS CFG file, which can be used for subsequent Kickstart installations, which, for example, for similar hardware would save you a lot of time and hassle in the event that the installations are to be duplicated or mirrored. So you can always place that ks.cfg file or copy it to ks.cfg file on your network repository and reference it using the ks option during installation. So that would be, for example, ks is equal to the location, let's say http://192.168.75.101/linuxcvt/ks.cfg, which would contain the options necessary to drive the process. And of course, any options that are not present would cause the Anaconda installer to prompt you for input. So we've installed Red Hat Enterprise. Let's reboot. And this will boot from the CD. If we select to boot from the local drive, we'll be presented quickly with the option to interrupt the process. And we can modify this entry by pressing P to unlock the grub entry. This is to prevent unauthorized access. And then, of course, E to edit the entry. And this is the kernel option. If we edit this line, we can force the resolution to be something that's acceptable, and then we can boot using the B option. Now notice the security lock. This is because we've encrypted the hard drive. If we press escape, we're prompted for the password. If we don't specify the password, we're unable to boot the system. Now the services are starting. And there's of course one caveat that every time you boot you'll have to supply the password to decrypt the contents of the hard drive, which means for remote configurations this may be less than ideal unless you have out-of-band access, perhaps via a DRAC card or some other means of connecting to the box outside of the console. This is the first time launch screen. Let's move forward. This is the license agreement. And this is an option to connect to the Red Hat network. This stage will skip it, but for production systems it absolutely makes sense to do so. And we'll tell it no thanks, I'll connect later. This is of course for patches, updates, so on and so forth. And we can create an ancillary user, Linux CBT. For day-to-day usage of the system. Here's the option to use network login. That allows us to configure LDAP. And if you need more control when creating the user, specifying home directory and so on, if you click on the Advanced button, this presents us with the User Manager application, which allows us to add the user and make changes that are non-standard. Otherwise, standard settings will be derived, such as placing the user in /home, /username. This checks the time with the appropriate offset from GMT. And this can be synchronized across the wire using NTP. Here is a default list of servers that will be consulted and configured in the ntp.conf configuration file. And this returns an error to configure kdump. That's not a problem. We can skip that. That should be cosmetic. And here's the startup screen. And now we have the option to log in. Of course, this is all of what we didn't see for the other installations. So to log in, we select the user, single click, then of course supply the user's password. And this will give us a GNOME desktop momentarily, and we'll be up and running. Here's the desktop. Typical settings are available, such as Open Terminal, etc. So we're up. And of course, the other consoles are available. This is Control-Alt-F2. This is Control-Alt-F1. As we've mentioned, the GUI has been moved to Control-Alt-F1. And as we cycle through 3, 4, all the way through 7, and it doesn't respond, back to 1. So we've again set up our system accordingly. Let's just take a look at 2. We'll log in. And a dump of the disk should show the configuration. So it's under dev mapper volume group, short host name, home, that's its size, roughly 20 gigs, and the root file system, which is 50 gigs, also under the same volume group, but a different logical volume. So our system's up. This is how we set it up. Insofar as the kickstart config file is concerned, it's anaconda-ks.cfg, which contains the settings surrounding the current installation.